And our lesson today is called Complex Numbers in Polar Form. Complex numbers in polar form. Today I'm going to teach you how to plot a complex number on a coordinate plane and how do you determine the absolute value of a complex number. Remember, a complex number is a real number and an imaginary number together. So we know that a real number can be represented on a number line, right? That is some knowledge that we learned a long time ago. That a real number can be represented on a number line. But we've never seen imaginary numbers on a number line before. Or complex numbers on a number line before. Well, today that's going to change. A complex number Z equals A plus BI is represented as a point A comma B in a coordinate plane. So if you have a coordinate plane, instead of having an x-axis, that is a real number axis, or your value of A, right? And instead of having a y-axis, that is your imaginary number axis, or your B. So for your real numbers, your positive real numbers go to the right of the origin. Your negative real numbers go to the left of the origin on the real number axis. And for your imaginary numbers, the positive imaginary numbers go above the origin on the imaginary number axis, and the negative imaginary numbers go below the origin. This coordinate system is called the complex plane. Super easy, okay? Example, plot each of the following. Oh, also for my in-class learners, I have your report cards today. For my e-learners, I don't know, I'm assuming they've been mailing those to y'all. I don't remember getting any this year, but I can't remember. I'm assuming they're mailing them, or you just see them on Student Portal. I'm not positive. Part A, we're going to plot z equals 3 plus 4i. So I'm going to draw a complex plane like I did above, but I'm going to put some numbers on there. So this could not be any easier. My real number is 3. The imaginary part is 4i. We're just looking at the 4, right? So where those two would intersect, that point right there, that's where z equals 3 plus 4i would be located, where my orange point is. Tough stuff, right? Yeah. So you're probably not on the imaginary number line, you're probably not going to see little i's on there, okay? So you have to know the real number part goes on the horizontal axis, and the imaginary number, that comes from the vertical axis. All right, so how about you try this one? I want you to graph z equals -1 minus 2i. And I'll be quiet. Did your point end up in the same place mine did? Real part's -1, imaginary part is -2. So they should be right about there, approximately. I don't have I'm not using graph paper, so. Y'all good with that? That's about as difficult as it gets for graphing complex numbers. But we're going to do two more. Any questions on A or B? Okay, so I got to go to my next page. So part C, we're going to graph z equals -3. It's missing a part. Is it missing the real part or the imaginary part? The imaginary part. That's okay. since we only have the real part, that point will be actually on the horizontal axis on -3 because you're missing the imaginary part. So we can only graph the real part, okay? Or technically, the imaginary part, isn't that the same thing as -3 plus 0i? So we're technically on the imaginary axis at 0, right? If you want to, either way you want to think about it. I should have not put that in the orange. I don't want you to 0. Okay, so part D, we're going to graph z equals -4i. So you can either think about it as you're missing the real part, or the real part is what? 0. And then the imaginary part. So where do you think that's going to go? Yes, so down here. Y'all cool with that? Okay. Now, that was the first thing I wanted to teach you, how to graph a complex number, okay? Now I want to teach you how to find the absolute value of a complex number. And what does absolute value mean again? We know it's always positive, but why is it always positive? What does it mean? Y'all can answer me, it's okay. Thank you. How far it is from 0, meaning the distance it is to 0, correct? And can distance ever be negative? What if I drove my car backwards all the way to work, which I would not recommend, it's kind of dangerous. But if I did drive my car backwards, would I be driving a negative distance? Would miles be coming off of my odometer? And no, it would not. Although I think in Ferris Bueller's Day Off, they thought it would. I think that's why they did that. Don't watch that movie. Distance is not 0, or distance cannot be negative. Absolute value means the distance a number is to 0, and that's why absolute value is always positive, okay? So remember, the absolute value of a number is the distance from the number to 0 on a number line. All right, well, we're going to be talking about the absolute value of a complex number, okay? So that's a plus bi. Like, how are we going to find that? Well, the absolute value of a complex number z equals a plus bi, denoted by absolute value of z, is the distance from the origin to the point Z in the complex plane. Okay, so let's draw another quick little graph. So if I was talking about this point right here, that would be Z equals A is positive, right? Plus BI, B is positive. So if I wanted to know the absolute value of that number, that means I'm looking for the distance that that number is to 0. Or the origin. So the absolute value of a complex number that would mean the absolute value of Z equals the absolute value of A plus BI. To find that, you do the square root of A squared plus B squared. Remind you of the distance formula? Or you could think about it as you're forming a little triangle here, a little right triangle, right? We know A squared plus B squared equals C squared. You're finding basically C of a right triangle, the hypotenuse, right? So that makes sense. But we know it wouldn't be positive or negative. We know when you take the square root of a number, it can be positive or negative. But since distance is always positive, you would only take the positive root. Okay? Any questions so far? All right. Let's label my paper real quick. Period, April 14th, 2021, page 2. All right. So in my next set of problems, we are going to determine the absolute value of each of the following complex numbers. Part A, Z equals 3 plus 4I. Okay, and not that you have to graph it each time. We're not going to. but we will on this first one, okay? But it's not, you don't have to do it to be able to solve the problem. So my real part is 3. My imaginary part is 4. So if this is z equals 3 plus 4i, we're looking for the distance that that point is to the origin. So what's your real part? 3. So we're going to let a equals 3. That's the real part. And what's the imaginary part? 4. So we're just looking. So the imaginary part's 4i, correct? We'll let b equal just the 4 part. So to find the distance, again, we just wrote this on the previous page. The absolute value of z, meaning a complex number, is equal to the absolute value of 3 plus 4i. And to find that, we take the square root of a squared, so that's 3 squared, plus b squared. Now, if those were negatives, you're squaring them, so it's always going to turn positive, right? Okay, so square root of, what's 3 squared? Plus 4 squared, 16. So that's the absolute value of 25, which is 5. 5 units, whatever that may be. Inches, meters, yards, centimeters, whatever. Tough stuff, right? All right, let's do example B. We're going to have z equals -1 minus 2i. So again, you can draw the graph if you want to. We don't have to draw a graph. We want to find the absolute value of the complex number. The absolute value of z equals the absolute value of -1 minus 2i equals the absolute value of, what's my a? -1. I'm going to square it. Make sure you put it in parentheses. Plus, what's my b? -2. I'm going to square whatever b is, so I'm squaring the negative as well. So that's the square root. What's -1 quantity squared? +1. Plus, what's -2 quantity squared? 4. So that's the absolute value of 5, which you could either, it depends. If it says exact value, well, square root of 5 is my answer. If it doesn't, if we're approximating, I would say approximately 2.236. Coolio. Y'all do this next one on your own, and then we're going to call it a day. Z equals 2 minus 3i. And then I'll give you an assignment tomorrow. But these notes are just super fast. So you'll all find the absolute value on your own. What y'all get? Square root of 13. Or, so that's going to be the exact answer. Or if we can approximate 13 square root is, let's go with 3.606. The exact answer is square root of 13. Approximate 13 is not a perfect square. So 3.606, either or. Y'all good with that? You have any questions? You know, totally confused. Okay, good. I didn't figure as much. All right, so we will have our assignment tomorrow. That's it for today. I know it's only 10:48. Easy breezy. If you did not finish the assignment on complex numbers from yesterday, you need to get that done ASAP and get it turned in today. And otherwise, we'll see you tomorrow. I'm going to pass our report cards here. Everybody at home, I don't know, check your mail, check student portal, see how your grades are. All tests have been entered. I think even my e-learners have been entered. So y'all also take this time to look at Schoology, or not Schoology, student portal, see what your grades are. See if there's anything that you could make corrections on, turn back in if you need to get that grade up. All right, and we'll see you tomorrow.